Hi guys, welcome. Today is day 25. We're nearing the end of the semester into our last unit for semester 1, 71 through 80. So today we're looking at lesson 71. So today we're looking at percent change of dimensions. So again, we've talked about a little bit in the past, our scale factors, if we're talking about perimeter, area, volume, and what we need to account for. So when we're doing a percent change in dimensions, just like when we're working with percents, when we're doing money or just basic numbers, we're going to need to think about it in terms of either a fraction or a decimal. And we'll show you what that looks like. Okay, so projectors, copy machines, graphic software, all of these, if we're looking at a scaled model of a building or something like that, we're going to dilate to reduce, dilate to enlarge, and then contract to reduce. So if we're reducing it, then the percent of overall change would be 100% because our starting point, our actual, screen or building or item or whatever we're looking at is 100% or 1 if we're talking about in number form, and then we're going to subtract the percent of decrease, and then if it's a dilation or an enlargement, then it's going to be 100% plus the percent of increase. And sometimes questions or even I see advertisements on TV and things, and it's kind of confusing. People throw around percents and you're like, is that exactly what they mean? Like when someone says 20% of the original price versus 25 or 20% off the original price. Well, those are two very different things. 20% of would be 20% times whatever the original price is. 20% off would get us to 80%. So 80% of the original. Or some people talk about like, oh, we grew 100%. Did you double? Are you now at 200% of where you started? Or are you at 100% right where you started at? So understanding the differences and reading through those questions, because sometimes I think even in public and things like that, people say a percentage and you're not really sure what that means. So anyways, just make sure you read through it thoroughly, and we'll look at some examples here. So if we were looking at the squares above, increase the size of the smaller square 20% means that the size of the larger square is 120%. So it's 20% up. So we'd say it's 120% of the smaller square or the original square. So we're multiplying that original one by 120% or 1.2 or 1 1/5 if we were doing it as a fraction. So understanding that we're not multiplying by 20%, we're not multiplying by 120, we're multiplying it by 1.2 because we need to convert it. So if we look at example 1 here, one square is 50% larger than another square. Again, read it. Is it 50% of or 50% more? In this case, it's 50% larger than another square. So the perimeter of the larger square is what percent of the smaller square, the area is what, and then provide examples. So let's just take a look at this. We're going up by 50%. Again, when it's ever these problems, just draw out what it's asking and then we'll do our best to make an original square. Let's see, a little bit more. And we'll say this is the enlarged square. So again, we're going up by 50%. So this one is our original, so it's 100%. We're going up by 50%, so we're adding 50. So this is now 150%. Gone up by 50%. And if we said it was just 50% up, then that would be half of it. That would be making it smaller. So make sure you read through the question of what's being asked. So as a number, we're going to say that our scale factor, obviously not multiplying by 150, but we need to convert this percent to a decimal. So we move the decimal 2 places to the left, and we get 1.5. So our scale factor is 1.5. So we want to know the effect on the perimeter, area, and we're doing an example right now. So when we're looking at squares, we know all the sides are equal. So I always start with what's the easiest number. We're probably making our sides 1, 1, 1. Okay, well, then that would make all of these sides, well, 1.5, 1.5, 1.5, and 1.5. So now we want to find the area and the perimeter of our original. That's pretty easy to do. We know perimeter is just add up all the sides, or it's a square, so we can just do 4 times the side. So 1 plus 1 plus 1, or 4 times 1 is 4. And now this one, 1.5 or 1.5 plus 1.5 is 3, 4.5 and 6. Right, so if we did 6 over 4, 4 goes into 6 once with 2 left over. 1 and 2/4 is equal to 1.5, which is equal to 1.5. So all of our perimeter did, since it's one-dimensional, it was just multiplied by the scale factor. The scale factor is 1.5. Our perimeter was 4. So we could draw it out and do it, or we can say, I know it has to be just the perimeter multiplied by the scale factor to give me my new perimeter. Right? Now, we talked about this a few weeks ago, but if it's area, then it's actually our scale factor squared, not just multiplied by the scale factor. And then when we get into three-dimensional shapes, there's 3 dimensions, so that's going to be our scale factor to the power of 3, because we're looking at 3 dimensions. So I'll show you what we mean. Area of this square is pretty simple. 1 squared, or 1 times 1, is just 1 units squared. Area of this one now becomes, we do 1.5 times 1.5, which becomes 2.25 units squared. So it wasn't just 1 times 1.5, because that would give us 1.5. It's 1 times 1.5 squared. So that's where the area is affected still by the scale factor, but it's affected at a greater rate. So perimeter was just multiplied by 1.5. The area was multiplied by 2.25. Or if we go back to our original, where we were working with, where we are working with our percents. Okay, well, 150% we converted to 1.5. So 2.25, if we want to convert that back to a percent, to say this is the area of this one was 150%. The area of this one is now going to be 225%. So again, 2.25 is our how much larger the area is. If we want to keep that in terms of percentage, well, now it's 225%. Okay, and that's what it shows down here. They used similar square, and let's say you did start with 2. Well, then you do 2 times 1.5, and then that would be the new dimensions. I just picked 1 because obviously doing 4 times 1 and 1 squared is pretty simple, but it still illustrates the point that we're talking about. So 50% greater means 150%. Perimeter went up by 150%. Perimeter went up by 150%. The area went up by 225%, or 2.25, because that is our scale factor squared. Let's look at example 3. The vertices of a square, again, just like when we're drawing a line or a segment or a triangle or a quadrilateral. In a coordinate plane, we just first plot all of our points. So we have 4, 4, 4, negative 4, negative 4, negative 4, negative 4, 4. Sketch the square in its image after 125% dilation, or that's going to become 1.25. So we need to convert that to 1.25, and then we're going to multiply all of these by 1.25. 4 times 1.25 just gives us 5. So 4 is going to become 5, 5. 4 negative 4 is 5, negative 5, negative 5, negative 5, negative 5, 5. So we just draw our first 4 points, connect the dots. We have our square. We dilate it, and now we have our new square that's been dilated. Okay, and let's take a look at what those look like. Okay, so here was our original. The original square is the inner square because we're doing a dilation, not a reduction or a contraction. It's getting larger. So the original perimeter, we could just count 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8 by 8 square. So 8 times 4 is 32. Now the larger square is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a 10 by 10. So a perimeter becomes from 32 to 40, which is 32 times 1.25 does equal 40. And then the area of the inner one was 8 by 8, so 8 times 8 is 64. The outer one was 10 by 10 square, so 10 times 10 is 100. So those would be our areas, and then 64 to 100, that's gone up by 1.25 to the power of 2. Which is 1.5625. As they indicate right here, if we were representing it as a fraction or as a decimal, that's what it would be. So 1.25 squared is 1.5625. And if we want to know, C asked us, the area of the dilation is what percent greater than the area of the original? And well, the original is always 100, and now it's 1.5625. So again, we move the decimal 2 to the right, and that would give us 156.25%. So how much greater is that than 100? Well, it's 56.25% greater. And this one probably talks about volume. Yeah, and the dimensions of the cube are increased by 100%. So again, this is where sometimes those words, is it 100% of the original, which means it didn't get bigger at all, or is it going up by 100%, which is the example right here. So it's going up by 100%, or our new one is going to be 100%, which was the original, plus 100%, which is now 200%. So our scale factor is 2. The other cube, the larger cube, is 2 times the dimensions of the smaller cube. And then what does that do to the volume? Well, we know perimeter, it's just the scale factor. The area, if we were doing lateral surface area would go up by 4 times, or 400% of the original. And then it's going to be 2 to the power of 3, which is 2 times 2 times 2, which is 8. And that's an 800% of the original, which means it's 700% increased. It's 700% more than the original. So again, read through the question, because yes, this is 800%, or 8 times the volume of this one, because 1 times 1 times 1 would be 1 cubic inch. 2 times 2 times 2 is 8 cubic inches, so it's 8 times greater, but it's saying by what percent is the volume increased? Well, it went from 100%, the original, to 800%. So we don't say it's 8 times greater. We don't say it's 800% of the original, even though those are true. What the question is asking is how much percent did it go up by? So it went from 100 to 800, which means that the volume increased percentage-wise by 700%. That's what I talked about. Sometimes when we're doing percents, we get in a hurry, don't really read the question correctly, or sometimes, if it's an advertisement or something, they may not be presenting it accurately, but we want to make sure we know what's being said. Again, it's 100% increase, not 100% of the original, which would be just the original. It's 100% increase, and then we want to figure out by what percent is the volume increase, not what is the percentage of the original, which would be 8 times greater or 800%. So again, just read it all the way through. All right, that's all we have for today. We'll do this practice set when we get to class. Have a good one. See you soon.